In this video, we're going to go over factoring by grouping. And when you use grouping to factor something, the polynomial usually has four terms. You can use grouping for other types, but it's primarily going to be used when the polynomial has four terms. Your first step, you're going to look at those first two terms and you're going to factor out the greatest common factor just like you've done previously, but you're only going to do it for the first two terms. Then you're going to find the greatest common factor of the last two terms. You're going to factor it out like you normally would. You find the greatest common factor, you put it on the outside of parentheses for the first two terms, find the greatest common factor of the last two terms, put it on the outside of the parentheses. Next, you're going to make two sets of parentheses. And here's how you're going to figure out what goes inside those parentheses. Put what is on the outside in one set of parentheses and put what's inside on the other set of parentheses. So the best way to do this is to look at an example. Here's our first example. Remember, it needs to be a polynomial with four terms for us to be able to use grouping. And the first thing I need to do is find the greatest common factor of the first two terms. I need to find a number and perhaps a letter that these two terms, just the first two, have in common. 3x to the second power. 3x to the second power. That is the greatest common factor of these two. I make an open parentheses just like I would when I'm factoring the greatest common factor. And how do I get what goes inside the parentheses? I divide each one of these terms by that. 6x to the third power divided by my greatest common factor, 2x. Negative 9x squared divided by 3x squared. 9 divided by 3 is 3. And the x squares cancel out. Now I need to find the greatest common factor of the last two. What number will go into both of those? A positive 2. How do I get what goes inside the parentheses? I divide each one of these by 2. 4x divided by 2, 2x. Negative 6 divided by 2, negative 3. What we're doing right here when we're factoring by grouping, we're seeing whether or not grouping can work. And how do I know whether or not grouping is actually going to work to help me factor this? What's inside the parentheses right here should be exactly the same. Look at this set of parentheses. It has 2x minus 3. Look at this parentheses. It has 2x minus 3. That means this can be factored. So what I've done here is put it in a form where I'm actually ready to factor it, because my next step is the factoring part, making two sets of parentheses. How do I know what goes inside the parentheses? Put what is on the outside. See what's on the outside out here? That goes in one set of parentheses. This 3x squared is on the outside, and this positive 2 is on the outside. Then I put what's on the inside. Notice it's exactly the same. It's supposed to be. If it's not exactly the same, then you've probably done something wrong. But whatever's inside the parentheses, I put in the next set of parentheses. That's how you factor something by grouping. So let's try another example. Again, for me to be able to factor something using grouping, it has to have four terms. This has four terms. I find the greatest common factor of the first two terms. I need a number that will go into 8 and 2. The biggest one, that will be 2. It looks like they have an x in common. And I need to see the greatest number of x's they have in common. It looks like I can pull a maximum of 2 x's out of each one of those. That's my greatest common factor. How do I get what goes inside the parentheses? I divide each one of these by this greatest common factor. 8 divided by 2 is 4. When I divide these, I subtract my exponents and I have 1x left over. Positive 2x squared divided by 2x squared, 2 divided by 2 is 1, and these x's cancel out to where I don't have any x's left over. Close my parentheses. I go to my last two terms, and I look and see if the last two terms has a greatest common factor. Looks like 3 will go into both of those. Positive 3 will go into both of these terms right here. How do I get what goes inside the parentheses? I divide each one of these by 3. 12x divided by 3, 4x. 3 divided by 3, positive 1. Everything's working out fine because what's inside the parentheses right here is exactly the same. At this point, I'm ready to make 2 sets of parentheses and figure out what goes inside those parentheses. In this first set of parentheses, I take what's on the outside out here and put it in this one. 2x squared and positive 3. The second set of parentheses, I put what's inside the parentheses. 4x plus 1. I just use grouping to factor this. Let's use grouping to factor this one. Again, it has to have 4 terms. This one has 4 terms. I need to find the greatest common factor of the first 2. Looking at these 2 numbers right here, looks like 5 will be the biggest number. That will go into 35 and 15. They have an x in common. In fact, how many x's do they have in common? It looks like a maximum of 2. So I put an exponent of 2. I close my parentheses. How do I get what goes inside the parentheses when I factor the greatest common factor? I divide each one of these by this. 35 divided by 5, 7. When you divide right here, you subtract exponents. 3 minus 2 is 1 left over. Negative 15 divided by 5, negative 3. X squared divided by x squared, 2 minus 2 is 0. There are no x's left over on the end. I close my parentheses. Now remember, when I factor something out of this one, inside these parentheses right here, it has to look exactly like this. That means this first one needs to be positive. Right now, this first one's got a negative right there. I need to factor out something that's going to change the signs because this one's negative and this one's positive. It needs to be a positive and a negative. I need to factor out what's in common, but I also need to factor something out that's going to give me a positive 7x right here. What can I divide by this to give me a positive 7x? A negative 7. Not only do they have a 7 in common, but I'm going to pull out a negative. And the reason why, when I divide both of these by negative 7, it's going to change the sign of these and make it like this right here. Negative 49 divided by negative 7, positive 7, with this x left over. Like here, I want this to be a negative 3. How can I make this a negative 3? 21 divided by negative 7, negative 3. I make my 2 sets of parentheses. I put what's on the outside in my first set of parentheses. And I put what's on the inside in my last set of parentheses. So if the signs don't match up, you can factor out a negative. By factoring out that negative, it's going to change the signs of what's inside here. I'm going to use grouping on this one because it has 1, 2, 3, 4 terms. First thing I need to do is find the greatest common factor of these first 2. Well, that would be x to the second power. Inside the parentheses, how do I get that? I divide each one of these by x to the second power. I subtract my exponents, and I have 1x left over. X squared divided by x squared. Anything divided by itself is 1. So sometimes students have a difficult time with this one because there's no numbers here, but there's like a 1 and a 1 in front of each one of those. 1 divided by 1 is 1. When you don't have any variables left over, you have to at least write a 1. The next thing that can give students difficulty, it looks like down here on the end, it has nothing in common. This is the only time you're going to factor out a greatest common factor of 1. 1 can be pulled out of each one of these. So I put a 1 on the outside of the parentheses. How do I get what goes inside the parentheses? I divide each one of these by 1. I look at these parentheses right here. As long as it's the same, everything is fine. And it is. I make 2 sets of parentheses. I put what's on the outside in one set and put what's on the inside in the other. So when it looks like you can't factor something out, you can always factor a 1 out and put it out here on the outside. That could always be a greatest common factor. This is going to be one of the few situations where you're going to factor out a 1 as the greatest common factor. How do you get what goes inside the parentheses? I divide each one of those by 1. And remember, Anything divided by itself is going to be 1. 5 divided by 5, 1. 10 divided by 10, 1. X divided by x, 1. X squared divided by x squared, still 1. I'm going to use grouping to factor this one. 1, 2, 3, 4 terms. I need to factor out the greatest common factor of these first 2 terms. It looks like the only thing they have in common is an x, and in fact I can pull 2 x's out of each one of them. I open my parentheses. How do I get what goes inside the parentheses? I divide each one of these by x squared. When I divide, I subtract my exponents. That gives me 1x left over. 2x squared divided by x squared. The x squares cancel out, and I have a 2 left over. Again, it doesn't look like they have anything in common. In fact, the only thing it looks like they have in common is a negative. So I could factor out a negative 1. Remember, I can always factor out a 1 out of anything. And they do have a negative in common. So I'm going to factor out a negative 1. And I'm going to open up my parentheses. How do I get what goes inside the parentheses? I divide each one of these by negative 1. A negative divided by negative is a positive. A negative divided by negative is a positive. This has got me exactly where I need it. I'm now ready to make 2 sets of parentheses. X squared minus 1 in my first set of parentheses, and x plus 2 in the other set of parentheses. One of the things I need to remember, I need to check these binomials and see if they can be factored again. And you need to be able to recognize, like we've gone over, the fact that this has a minus sign, this is a perfect square, and this has an even exponent. So this part right here is going to have to be factored again. This one has a plus sign, so it can't be factored. To factor this, I make 2 sets of parentheses, and then I'm going to bring that x plus 2 down. This part is what I'm factoring. Since it has x squared, I put an x here and an x here. I take the square root of 1, 1, and 1, and one of them I put a plus sign, the other one I put a minus sign. Can any of these be factored again? This one cannot be factored again. It has a plus sign. This one has a minus sign but no even exponent. And this one has a plus sign. So be wary of these binomials that can be factored again. Make sure it has 4 terms. I'm going to factor out the greatest common factor of these first 2. The biggest number that will go into 8 and 16 is 8. I've got a variable that's in common. In fact, how many do they have in common? That would be a total of 3 x's in common. Make my open parentheses. How do I get what goes inside the parentheses? I divide each one of these terms by this greatest common factor. 8 divided by 8 is 1. When I divide, I subtract my exponents, and I have 1x left over. 16 divided by 8 is positive 2. And once I subtract my exponents, I get x to the 0 power. That means I have no x's left over. Look for the greatest common factor of the last 2. 9 was the biggest number that will go into both of these. Positive 9, and it looks like they have an x in common. They have a total of 1x in common. Make my open parentheses. How do I get what goes inside the parentheses? I divide each one of these by 9x. 9 divided by 9 is 1. When I subtract my exponents right here, I have 1x left over. 18 divided by 9 is 2, and I have no x's left over. I make 2 sets of parentheses. I take what's on the outside of the parentheses, put it in the first, and take what's on the inside of the parentheses and put it in the next. Again, you need to look and see if these binomials can be factored again. In fact, this first one, I can factor out a greatest common factor of this first one. What do these 2 terms have in common? An x. So I'm going to factor out an x out of each one of these. When I divide, I subtract my exponents. That gives me 2 x's left over and no x's left over right here. So again, make sure that you check these binomials and see if they can be factored again.